Welcome to your 4.4 lesson. What I'm going to do is go over the majority of this lesson. The answers of the entirety will be on Google Classroom for you to double check, but so this doesn't turn into an hour-long video, I'm going to just show you certain parts that are key areas, and if you have any questions about the sections that I don't post here on Tuesday, we can go over it and fix those ideas. What we're going to start off by looking at is taking our ability to factor that we learned in Unit 3 and bringing it into quadratics. So we've already established that this section right here, this equation is our factored form. And this equation here is our standard form. This is the form that we have been factoring in Unit 3. What we're going to do in this section right here is look at the different things that we can see between these two. The idea is that our factored form and our standard form are identical. So if we were to expand our factored form using FOIL, we would get the same answer as our standard form. As you can see, as I'm factoring this out, as I'm foiling this out, you get the exact same answer as what our standard form is. But let's double check that this standard form is in fact the same as that factor form. So what we're going to do first is we're going to look at it. We're going to see that there is no GSCF to take out. So that means our product is negative 15, our sum is 2, and we know that 5 times negative 3 gives us negative 15, and positive 5 plus negative 3 gives us 2x. So we're just going to open up our brackets, put in our factors. Again, this only works for simple factors. And behold, that is our factored form. So you can look at both of these items here and notice that they're the same. So technically speaking, a factored form and a standard form of the same relation will always be identical. So to answer this question here, do they represent the same relationship? Yes, they do, because we can factor or expand both and they'll be the same. What kind of information can we take from both? Well, factor form, we can see our zeros, which are this R and S. We can see our stretch, which is the A value, which gives us our direction of opening. Standard form, instead of being able to get our zeros, we get our y-intercept, and the stretch and direction of opening is the same. So let's go back to remembering factoring. So factoring here, we look at a trinomial, and we're going to need to do one thing first before we can do anything, is always to take out our GCF. I'm not going to go through this one, it will be up online, but I'm going to look at this example here for us to do in this video. So first thing we need to do is look to see if there's a GCF. So we've got 3 in front of the x squared. We would prefer this to be a 1. However, let's see if we can take it out. So 3 does go into 15, and it does go into negative 42. So let's take out 3 from each of them. Again, you don't need to show this particular step like this. You can just go straight to giving the answer with a 3 on the outside. So we divide by 3 on each item, and now we have an A of 1. If there was still a number here, we'd have to use decomposition, but since this is a simple trinomial, we can go straight to looking at our product and sum. So our product is negative 14, our sum is 5, and our factors for this will be positive 7 and negative 2. And since this is a simple trinomial, we can just open up our brackets. Oops, we don't want that 2 there. And slap in our factors. And behold, it is factored fully. Again, this one over here will be on Google Classroom in the filled out lesson. Sliding on over. So this question here is asking us to determine the maximum or minimum y value of each parabola. So what that means is we need to go find our vertex and specifically the y value of our vertex. So what we're going to do first here is we are going to factor out any greatest common factor. So there's two ways to go about this. I'm going to show you two separate ways to figure out certain items. So for this one here, we're going to do the long way, which includes factoring. So we've got -4, 18, and 10. Okay, -4 can't go into all these, but -2 can. So we're going to take out -2 as our GCF. And that leaves us with 2x squared minus 9x minus 5. We're going to get our product, which is -5, our sum, oh, sorry, product is not -5. We need to multiply our a here by our n. That gives us -10, common mistake we've all made, and our sum is -9. Our factors, therefore, are -10 and 1. Since this is a complex trinomial, we're going to need to decompose. So we get 2x, -2, bracket 2x squared. And we're going to do -10x plus x minus 5. At this point, we're going to decompose. So we take and factor out the most we can from this section and the most we can from the second section. So we get -2 bracket. I'm going to change colors here. I'm going to take out 2x. This leaves me with inside the bracket x minus 5. And for this one, well, we want it to be the same as this bracket, so we want this to be the same. So that means we need to multiply by 1. So we get plus 1, x minus 5. We bring these two together, and our factored form is -2 bracket 2x plus 1, x minus 5. At this point here, what we want to do is go find our zeros. So to find our zeros, we make each of these brackets equal to 0. So the step will be find zeros. So that means 0 equals 2x plus 1, and 0 equals x minus 5. So we move the 1 over, we get -1 equals 2x. We're going to divide by 2, and x is going to equal -1/2. Oh, well, that's not a fun number to deal with. We're going to put it as a decimal just to make life easier here. And this one's nice. 5 equals x. Beautiful. Excellent. For those who can't see what we did, we added 5 to both sides. Okay, now that we have our zeros, we need to go find our AOS, which is our x value of our vertex. I'm just going to draw a line down here, separate out a bit, and go up here. So what we're going to do over here, step 2, find AOS. Okay. How do I go about doing that? Is the lovely equation is x equals r plus s over 2. Our r and s, aka our zeros, are this time -0.5 plus 5 over 2. That is going to give us a very unfortunate number of 4.5 divided by 2, which is 2.25. So that is our AOS. And what we're going to do now is take 2.05 and we're going to go find out what our y value is when our x is equal to that. So this is our x value of our vertex, and now we're going to find out our y. Now, not always are the numbers going to look like this. This is an unfortunate number. Hopefully, most of the time, they are positive or a whole number. Not annoying decimals. However, we will work with what we have. Personally, when I go through these, I like to use this version so I don't have to square. Just it's a lot easier to deal with this. So that's what I'm going to use. I have y equals -2 bracket 2x plus 1 x minus 5. So now I am going to sub in x equals 2.25, get -2 2 bracket 2 bracket 2.25 plus 1, and then I put in 2.25 here minus 5. Start doing that work. Okay, so we got negative 2, and that is going to be timesing by 2 times by 2.25 gives us the 4.5 again. Add 1, and we get 5.5. And here, it's negative 5, subtract 2.25. Let's go get a calculator for that. I'm not trusting my brain today. Minus 5 gives us negative 2.75. Now we're going to multiply all this together. And that's going to give us 30.25. So our answer to this one is, therefore, our maximum y value is 30.25. Okay, so the first one, what we did is we first factored it and then found our 2 zeros and then did our AOS. Now, see, if we don't already have it in factored form, there is a shortcut. If it's already in factored form, just go about finding your zeros. But if we are looking for our AOS and we have standard form, there is a faster way to do this. The equation is x equals negative b over 2a. In this case, our b is this 5 here. Our a is this 0.5. So when we're going about doing this, what we're going to do is put negative 5 over 2 bracket 0.5. That is going to give us negative 5 over 1, which is just negative 5. That is our AOS. I'm just going to drag this down so you can easily see what's going on here. And once we have our AOS, we're just going to go find out our Y. Again, this only works if it's in standard form. If this is in factored form, you have to do the way above. So we're going to take our function here, y equals 0.5 bracket negative 5 squared plus 5 bracket 5 plus 8. So we're going to get 5 squared, negative 5 squared, which actually equals 25. And we're going to have 5 times by 5, which is 25 plus 8. Now, this is not going to give us a nice number. This is going to give us a decimal, but that is fine. 25 divided by 2, which is actually 25 times by 0.5, will give us 12.5. We're adding, oh, sorry, this is negative 5 here. So this would be negative. Make sure that we are always checking our signs so we don't make those small mistakes. We throw that in a calculator and we are going to get, buffering, negative 4.5. And that is our Y value. Now we're going to look at this A to see if this is opening up or downwards. Now this A is positive. So since it's positive, this will be a minimum. So we can say, therefore, the minimum Y value is negative 4.5. Okay, the next question is two parabolas are defined by y equals x squared minus 10 and y equals 20x minus 5x squared. All right, so we're going to actually mix those two different options together. I'm going to change color so you can see that these are two separate equations, and I will color code when I am going and hunting for the answers. So starting off, what we're going to notice about the, change colors there. First equation in green, which is y equals x squared minus 10, is that there's not much we can take out of both. So we need to go think about how we could factor this, or if we can factor this. The second one, however, this equation right here, we can use that x minus b 2a, okay? This one here, there's not much we can actually do with it. If we were to graph it, we would find out that goes down. Here as well, we can actually use this version as well. How? You're going like probably, where is bx? There is no bx. Well, if bx isn't there, the b is 0 because it multiplies it out. So this one we can also use this shortened version. Again, you could conceivably go about factoring this one, which is actually what I'm going to do, but you could use this version instead. So the first one, we're going to use that short version. So in this case, we're going to find our AOS first. We're going to use that equation that we have, negative b over 2a, and hint, nudge, nudge, this is going to equal 0. So we get negative 0 over 2 bracket 1, which gives us negative 0 over 2, which equals 0. Beautiful, we have our AOS. What we want to find out next is find y value. So we have y equals x squared minus 10. Where x is, we're subbing in our 0. 0 squared is 0, so we're left with negative 10 for our y. So that means our vertex is 0, negative 10. Perfect, great. All right, so we have our vertex for the first one. This will help us to start figuring out our vertices so we can check the distance between the two of them. So with this one, I said we're not going to take the short form. We are going to go and take the long way, where we do factor. In this case, it will be a common factor. So step 1 here, factor to find zeros. What I'm going to do straight off the bat is I am going to rearrange to be in descending order. So the negative 5x squared goes first, plus 20x. I can take negative 5x from each, so I get negative 5x, and then bracket x minus 4. I'm going to now go find our zeros. I'm going to make this statement equal to 0 as well as a bracket. So 0 equals negative 5x, and 0 equals x minus 4. This one here will become positive 4x. We move x to either side, so if you want to see it, you can write it out the long way. You don't have to. And over on this one, we're going to divide both sides by negative 5. And 0 divided by negative 5 is, well, 0. So 0 equals x. Those are our two zeros. Step 3, find AOS. This is 1r, this is our s. So we get x equals 0 plus 4 divided by 2. 4 divided by 2 gives us 2. And last but not least, we want to go and find our vertex. We're going to take that 2 and place it into our equation. So find y. So we had -5 2 squared plus 20 x. So we put that 2 where the x was. So here we go. 2 to the power of 2 is 4. 4 times -5 gives us -20. Now 20 plus times by 2 gives us 40, which gives us a y of 20. So therefore our vertex is 2 and 20. Okay, we're not done yet because why do all this work and not have to do one more step? What we want to do is find the distance between the two vertices. Now we've already done our unit on analytical geometry, so we need to go all the way back in our brain and remember that the formula for distance between 2 points is the square root of bracket x2 minus x1 squared plus y2 minus y1 squared. So we're going to shove in our points in the respective areas. So I'm going to label the blue here. This will be our second point. Oops, that's not what I wanted to use. This will be our second point, and this will be the first point. So I'm going to start subbing our values in. So we get square root of 2 minus 0 squared plus 20 minus, I believe it was 9, it's 10, yep, squared. We get the square root of 2 squared plus 30 squared, which gives us the square root of 904. 2 squared, 4, 30 squared, 900. And that's going to give us a distance of 30.1 units. So that's all the steps that we do to find out the distance between the two vertex. So we have to find the vertices for our first equation, our vertices for the second equation, and then we use our distance formula all the way back in the day from before March break. I'm going to do this one with you guys on this video, and then question 4, the answers will be up, but you have made it most of the way through this video. So here's the deal. You guys know I'm away today. To prove that you have listened to this video, I want you at this point to go onto Google Classroom, go to your grade update, and I want you to comment your favorite color. So again, go to Google Classroom, go to your mark update, and comment what is your favorite color. Don't tell anyone else in the class that there was this comment in this video about that. That is for yourselves. On Tuesday, we will have a discussion. So let's get into this. So for this one, it wants us to graph from a beautiful, lovely standard form. Now, standard form doesn't tell us much, so we're going to have to do a lot of things with this information. The one thing that standard form does tell us is our y-intercept. So we can already answer our y-intercept is y equals 48. I have a feeling that that's not going to be very useful for us, and that's going to go off the graph. However, let's look at some other things. We can also easily find out our axis of symmetry from this. So let's go ahead and already start looking at that. There's 2 ways we're going to be able to do it. I'm going to show you the other way, and then we're going to prove that we can use the other way for this as well. Because we have the one system of the x equals -b divided by 2a when we have standard form, and when we have factored form, we can use r plus s divided by 2. So in this case, it would be 24 divide by 3, 2 times by 3, and this is negative, equals x. 2 times by 3 is 6, so negative 24 divided by 6 gives us negative 4. We'll double check to see if this works for both methods. Now, what we want to do here is so we can find out our zeros, we need to factor this function. First step is always to see if we can take out a GCF. 3 can go into 24, and it can also go into 48. So we're going to take out 3. Once we do that, we have 3 bracket x squared plus 8x plus 16. And what we're going to do here is look at our product, which is 16, our sum, which is 8, and our factors are going to be 4 and 4. Oh, look, square root at the top, square root at the bottom. That was a perfect square trinomial. Beautiful, excellent. We are just going to go about writing that. Remember, we're not always going to see them right away, and that is fine. So there's our perfect square trinomial. So our zeros in this case would be making both of those brackets equal to 0. Yes, both brackets will still yield the same amount, but it's always good habit to do both to get the practice. Now let's confirm that negative 4 is indeed our AOS. We're going to use our R and S method over here. I'm going to keep it as green. So in our RS method, we would take negative 4 plus negative 4 and divide by 2. So it's our R and our S. Negative 4 plus negative 4 gives us negative 8 divided by 2, which gives us negative 4. As you can see, both of these methods work. It really depends on what you already have in your choice to decide which one to use. Sometimes on tests, I'm going to explicitly tell you to use the factoring method. And yes, I will get you to go all the way here. Sometimes I'll be okay with accepting just this. Always read the instructions for what method you are supposed to use. Vertex. How do we go find about our vertex? What we're going to do here is we're going to take our AOS and place it into our equation. I'm going to use our factored form because it's just faster to use. So we have y equal 3 bracket, and we're replacing our x with negative 4 minus 4, plus 4 squared. What that's going to give us is negative 3, because negative 4 plus 4 gives us 0 squared. 0 squared is 0. 0 times by 3 is 0. So that means our vertex is negative 4 and 0. Let's start plotting what we can plot. Okay, our y-intercept is way off this grid. It's nowhere to be found. Our 0 can be located, which is negative 4 and 0. I don't know. This is an example where we're going to need to use our step pattern. So as we remember, our step pattern is always A, 3A, 5A, 7A. We hardly ever use the 7A, but it's always good to just kind of keep that pattern in our mind. In this case, our A, let's go up and see. Our A was 3, so we're going to say A equals 3. So our first step pattern is going to be 3. Our second step pattern is going to be 9. Our fifth, 3 times by 5 is 15. And then the last one, 3 times by 7 is 21. These two we're not going to use. But let's start plotting the other points. So our first step pattern was 3. So we go over 1, up 3. Over 1, up 3. And then from this new point, we're going to go over 1 and up 9. 3 plus 9 gives us 12. And over here, 12. And we connect the dots as best we can. Remember, it might be a little bit messy. That's okay, as long as you're not squiggling between. And that is our graph. The expectation for you to do now is complete 4, try it out. The answers will be online. I will also be posting online your homework and what you're expected to do for the rest of the period. Okay? Have a good day, and I will see you tomorrow.